Go.
Welcome to static electricity. This is our first part of the course. Before we get into the electronic part, we want to understand static electricity. What is it? Electricity is the word called electron from the English, which comes from the Greek word for amber. You see in the picture, it shows what amber looks like. So the word electronic basically comes from amber. Here people have the amber decorated, looks like a circuit, looks like jewelry. All matter is made up of atoms, which are themselves made up of charged particles. Atoms have a nucleus, consists of a neutron and proton. They also have surrounding shell that is made up of electrons. Typically, matter is neutrally charged, meaning that the number of electrons and protons are equal, the same. If any atom has more electrons than proton, it is negatively charged. If it has more protons than electrons, then it's called positively charged. Triboelectric series. Some atoms hold on to their electrons more tightly than others do. How strongly the matter holds on to electron determines its place in the triboelectric series. If a material is more apt to give up electrons when in contact with another material, it is more positive in the triboelectric series. If a material is more apt to capture, means to grab more electrons when in contact with another material, it is more negative in the triboelectric series. Here's a list. The human hand usually too moist through very positive. Rabbit fur, you see glass, human hair, nylon, wool, lead, aluminum, wood, amber, and so on. You see all these different materials that are very, like Teflon is very negative charge. So some of them have positive charge and negative charge, and what we're looking at is from positive going straight down to Teflon, the most very negative. What's inside an atom? Atom is made up of three types of particles: the electron, proton, and the neutron. The electron symbol is a minus, or you guys can call it a negative symbol. The proton is a positive. The neutron is represented by a 0. There's a diagram of an atom. You see in the middle has plus and O's, the neutron and protons, and look around them, the orbiting of them. We just lost the electron. Look, we lost another electron. This is on the outer shell. Now, the charges could be positive or they could be negative. When you have two positive charge, boom, you see what happened? It repels. See when you have the same poles, they repel each other. Now, these two poles, one is positive and one is negative. When we click on them, what happens? They come together. So you see the two charges come together because one is positive and one is negative. Now, insulators and conductors. Insulators don't, so remember that word, insulators don't let electrons flow through them. Conductors let electrons flow through them. So let's see. See this one here? You see that? This one, the conductor is allowing the electricity to flow. See how it's flowing? It's moving a line, it's flowing because it's a conductor. The insulator does not flow, it stays where it is. Electron stays stuck on the surface and don't move. That's static electricity. So Mr. Adam, do you know what static electricity is now? Alright, good. Charge objects. If you look at this middle one, it's neutrally charged. Do you know why it's neutrally charged? If you look at the diagram, how many protons it has? and how many electrons it has. It has 3 protons, 3 plus sign is proton, and 3 negative electrons. So they balance each other. 3 and 3 is equal. So it's neutrally. Now let's look at this one here. The one on the left. Positively charged object. Why is it positively charged? Count how many protons are there. How many protons are there? Count. We have 1, 2, 3, 4, 5. 5 positive proton and 1 negative electron. So that means there's more proton than electron, so it's positively charged. The next guy on the right hand side is negatively charged object. Why? Let's count them. How many protons? 1, 2. How many electrons? 1, 2, 3, 4. So there's more electrons to it, so it is negatively charged. You get it? Alright. 3 ways to charge an object. 1 by friction, 1 by induction, and 1 by contact. How do they become charged? Contact. Let's see. Contact means electrons get passed from one object to another when they are touched. Induction, electron in the object moves away or towards another charged object is placed close to it. So this is the movement of electrons. Do you remember the example when you take a balloon, right, and you rub it on your hair? Do you remember that? What happens when you take a balloon and you rub it on your hair? Not a wet hair, when your hair is dry. What happens to the balloon? It creates static electricity. It has charges. We're going to show in this example what happens, but you'll be able to take that and you'll see your hair will pull towards it. What happens to the little guy? Look at the little guy. We take the balloon and we rub his head. Friction. We created friction. Now we're rubbing it. Well, every time we're rubbing it, look what happens to the balloon. It's taking away some of the electrons. You see? It took the electrons away from your hair. You see the little example? Now, what happens when you rub a balloon on your head and put it against the wall? What happens when you do it? The balloon actually sticks to the wall. Rub a balloon on wool or a sweater. The balloon collects negative electrical charges on its surface, and the wool collects positive charges. When you stick the balloon on the wall, which does not have any excess of either charges, the balloon will also stick to the wool, although the charges may jump back to the original material in a short time. Rubbing a balloon on wool sweater creates charges on the surface. So normally when you do it, the balloon will actually stick to the wall. You remember this one? You remember this experiment? When you walk on a carpet, right, and you create static electricity, you're generating, and when you go touch a door handle, you get zapped. This is what protons resting in the door handle, and the electrons from your hand gets transferred, and you go zap, because positive and negative attract. The laws of electrostatic. Opposite charges attract and like charges repel, like our example we showed before. So if you look at this, is almost this is the same principle for magnets, same principle for electricity. So the positive, we have a negative and a positive, they attract. If you have 2 negative, it repels, and 2 positive repel. So like charges repel, opposite charges attract. When is an interesting experiment to try is that if you take a magnet and you bring it close to the water will bend. The water will bend because of the electricity, the charges, the static electricity. Static electricity is charges that don't pass through an object, rather they build up on the surface. So it doesn't pass through, it builds up on the surface, Created by friction, one substance loses electrons to the other gains electrons. That's friction. Only electron moves. Both positive and negative charges are created by the removal of electrons. Ease at which electrons are moved depends on the Triboelectric series, depends on the chart where they stand. Touching a charged object to another object causes the charge to be lost. This is called discharging electricity. Ease at electrons losing. See, the top part is positives and the bottom is negatives. So we showed the chart before. So from your hand is more stronger and positive, and go down to here all the way to plastics are more negative. Sparks are created when a charged object comes close to either an object of the opposite charge or a neutral charge. The larger the built up of charge, the larger the sparks which jumps across the gap. Remember on our door handle, if you went and you have runners on carpet and you go zoom 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 back and forth, the more you go back and forth, the more you build up. The bigger when you touch the handle, the bigger the charge you're going to have. Grounding helps to prevent build up of charges. So you can actually ground yourself to prevent static build up of charges. Measuring a charge. An instrument called an electroscope is used to measure the amount of charge in an object. So you can measure the charge in your finger, you can measure the charge in any object. Do you remember this at the Science Museum? They have a big ball, 100,000 volts, and then they put somebody on a pad. You stick your hand on this thing, they run the voltage. It's interesting that you can have so high voltage, but there's no amp. If there's amp, you'll be dead. Amp is the thing that kills you and not the voltage. So look at the guy's hair. He shakes his hair and all his hair stands up. You remember this one? Do you remember this one at the Science Museum? Here it gives you a better idea. They have the silver ball. Look at the girl's hair. You see how nice her hair looks like? This is what happens when it transfers a gain of power. And to stop it, he has the wand, which is a ground. You see, he has a ground. This thing here is a ground. See the wire? When he touches this, it discharges electricity, and then all the hair falls down back. Uses of static electricity. Spraying of a car. Let's use as an example. Negative spray gun. Positive car. See, when they spray paint a car, they use the signs of static electricity with positive and negative, so you don't waste the paint. So we look at the power sources in the middle between the negative spray gun and the positive card. So they shoot the paint, and the paint sticks onto, because remember that positive and negative attract. So if the positive and negative attract, so the negative paint, the paint that has negative ions, it's going to attract to the positive of the car. So no paint is wasted at all. The paint spreads out as each negative drop repels. No paint is wasted as the positive car attracts the negative paint. Amazing. Let's look at a different one. Removing smoke from a power station chimney. This is a chimney. They have negative plates on one side, positive plates on another side, and they're going to put a fire on. That's the fire from the chimney. So you can see the iron. Look at them going there. You see? They know which side to go. You see, the blue one is negative, and gets attracted to the red one, which is positive, and the red one gets attracted to the negative. You see that, how they clean the chimney? By using negative plates. No smoke leaves the chimney. Amazing. So all the carbon that comes out from the smoke gets collected on the two sides with a charge. Amazing technology. Earthing petrol tankers. This is a tanker that's full of gasoline, gas, petrol. gasoline to fill the cars. Pressure rubbing against the pipe can build up static electricity, which could cause an explosion. So you can have an explosion. Well, how do they fix this problem? By grounding. You see, that's a symbol for ground. They ground the vehicle. The tanker is joined to the ground with wires to stop charges from building up. What causes lightning? Lightning actually is just static electricity on a much larger scale. Rubbing is caused by air moving around. The thundercloud's bottom is usually negative and the top is positive. Here's our example. See the discharge of electricity. We have the tree is positive, cloud is negative, the ground. That's why the lightning comes towards the trees and the ground, because of the positive and negative being attracting. You see? Look again. Look at this example here, positive, negative. See, transfer of electrons. This is a lightning rod is used to prevent lightning causing damage to electrical appliances. By having that, it grounds the lightning. Okay, so this is the end of the static electricity series. This series was basically to give you an introduction, just to have a basic concept of an idea of static electricity. It's one form of electricity. This can be created, as what we talked about, and it's very good, and it's very dangerous in many cases, because in electronic circuit, static electricity is enough to blow your motherboard, blow your RAM, blow your CPU, and blow different components. So you have to be careful of static electricity when operating or going inside of a computer. Many electronic devices can be blown by static, so you have to be careful with static electricity. So that's the end of this section. We thank you very much and have a great day.